Bismillahirrahmanirrahim. Good day, everyone. In this video, I will be solving a problem based on pneumatic system. The problem states that part of a production line involves a quality check. If goods are seen to be faulty, then they are pushed off the conveyor by a single acting cylinder. Here, please note that it is saying single acting cylinder. Two people are used to make sure that no faulty goods leave the factory. They operate the cylinder by pressing a button. Here in the picture, you can see this is a single acting cylinder and we have two inputs here. If either one of them pushes the button, then the goods will be discarded. It will fall into the scrap bin. This problem can be solved by using OR logic. If the input where if input is 1, then the output will always be 1. If both input is 0, then the output will be 0. So let's draw the circuit here. First, the single acting cylinder. We have a spring inside. Now to control this single acting cylinder, I need two DCV. In the left side, we have a push button and the right side, we have a spring returned. So in initial position, the right side will be actuated. This is my power supply. This is my exhaust. Let's copy this. We have to connect these two valves with a shuttle valve. Let's make some space. To develop the OR logic, we need a shuttle valve. This is the shuttle valve, which have two inputs in this side and one output in the upper side. Let's connect this. I will make the connection with another color. Perfect. Let's talk about the shuttle valve. Let me show you the cross-sectional area of the shuttle valve. So this is the cross-sectional area of the shuttle valve, which have two input. I'm calling this input 1 from this side and input 2 from this side, and have a single output this side. This shuttle valve has two positions. Position 1. In position 1, I am giving input from this side. So if I give input from this side, the ball will get stuck on the right side. Because of that, this right side will be blocked and output will come out of here. So fluid flow will be like this. In position 2, if I give airflow from the right side, the ball will stuck at the left side and the path of the airflow will like this. So this is the OR logic. If any input is 1, then output will be 1. But there is a question. What if I give both input to 1? What happens if I give airflow from both sides? Where will be the ball go? So there is two cases. Case 1, giving input at the exact same time. Then the ball will go to the middle. And case 2, not simultaneous. The ball will go on that side which was pressed later. So if I give airflow on the left side first and later on the right side, then ball will move here. And if I do exactly the same time, then ball will move to the middle. Let me show you all of this in the simulation. So this is my software. I need a single acting cylinder, two DCVs, making a push button and spring return, power supply, exhaust, copy and paste. Now I need a shuttle valve. I did exactly as I discussed. Let's simulate this. Let's push this button. Now let's push this button. So when I push this button, fluid is moving from the left side to the cylinder. When I push the right button, fluid moving from right side to the cylinder. If I push both buttons, see this side blocked because I did not push simultaneously. First I push the left button, then the right button. Another question arises. Pay attention to question number D. Someone has suggested changing the shuttle valve to a T-piece. Why is this not a good idea? You might want to build this circuit to investigate. What is a T-piece? Let me show you. So this is a shuttle valve. If I just join this without a shuttle valve, it becomes a T-piece. Here is the cross section of a T-piece. So T-piece is just like a shuttle valve, but it has no ball inside. Let's simulate with a T-piece. Let's copy this and paste. Remove the shuttle valve. To make a T-piece, just join these port lines. Okay. Let's see the action. So actually it's working just as like the shuttle valve. So what's the difference? So there is a major difference. I will show you the difference in two ways. First, watch the shuttle valve. See, there is no flow in the right section. Now let's watch the T-piece. See, we have flow on the cylinder, okay, but on the right side we also have flow, and this flow is going to the exhaust. So this is a loss. Let's show you the another way. Here I am taking pressure measurement. Okay, for the shuttle valve, you can see 0.6 megapascal. Now for the T-piece, 0.44 megapascal, very much lower than the shuttle valve. So if we don't want any loss or don't want to decrease the pressure, then shuttle valve is the way to go. Let's see another problem. Here The problem states that a pneumatic circuit has been devised for use in operating a sliding door. It must be possible for the door to be opened or closed from both the inside and outside. The speed of the door should be controlled when opening and closing. So one thing is to be careful of the speed. Let's draw the circuit. Suppose this is the inside and this is the outside. I need a double acting cylinder for this purpose because it said that both opening and closing. To control this double acting cylinder, I need a 5x2 direction control valve. Both sides will be pilot operated. The left side will be for opening and the right side will be for closing. I need to make room. Now I need a shuttle valve on both sides. On the inside, we need two direction control valve and outside also two direction control valve. Let's copy this. Okay, we have four 3x2 direction control valves. Let's label them. Suppose this is our door. Forgot to give supply and exhaust. Let's connect this. These two DCBs connected with this shuttle valve, and these two DCBs will be connected with this shuttle valve. And after that, these two shuttle valve will be connected with the pilot line. One thing the question stated that it should move slowly. To control the velocity, we have two options. One is the meter in circuit, another one is meter out circuit. I have discussed these two in my previous video. So I will apply the meter in control in this circuit. The meter in circuit is controlling the input fluid. First, draw two restrictors. Then I have to draw the check valve. I will block this side with the check valve. So fluid will go through this restrictor and I will allow flow through the check valve on the right side. Fluid won't get restricted when exiting the cylinder. But if fluid will go through this side, it will get restricted. But when exiting, it won't be restricted. So this is called the meter in circuit when I am restricting the inflow in the cylinder. Let's simulate this circuit. I will be going fast. So I did exactly what I discussed. Let's simulate. First, let's restrict the flow. only 13% will open. So from the inside, that's open and close. And from the outside, that's open and close. So this was the solution. I hope you got it. If you didn't understand any portion, please feel free to comment.